Hello friends, we will discuss about the main mechanical subjects. First of all, in mechanical subjects, there is three aspects will be there. First part is production, and next part is thermal, and next part is design part. Now, any competitive exam, any competitive exam, it will cover three subjects. One is production, another one is thermal engineering, another one is design. It will cover all competitive exams. Like example, you imagine like a in Andhra Pradesh exams, AP ESET exam, and next ISRO and DRDO, SSC JE, RRB JE, RRB ALP, and technician jobs. In that technician jobs, it will be like a in shipyard also technician jobs will be there. In plants also, some of the plants also technician jobs will be there. And mostly it will cover like in Telangana also TSECT, Telangana State Government ESET exam. It will cover like a AP ESET and TS ESET, ISRO exam, central government, DRDO exams, SSC JE, RRB JE, ALP exams, technicians like plant technicians, shipyard technicians. For these, all these, we have to study these subjects: production subject, thermal subject, and design subject. First, in that production, discuss detailedly. First, main thing is that workshop technology. Workshop technology. And in that workshop technology, what you will learn in that, it is carpentry tools, pinsmithy tools, and next forging operation tools, and fitting operation tools. Like only in this workshop technology, we will discussing about the only tools and measuring instruments. Tools and measuring instruments. Only we are learning about the tools and measuring instruments. And after that, we are learning about the manufacturing system, casting and welding. This is the manufacturing systems. In this, we are discussing about the casting and welding manufacturing systems. In third, we are discussing about the machining operations. In machining operations. In machining operations, different machines will come to picture. Different machines. One machine is a lathe machine, milling machine, and shaping machine, and grinding machine. These are the different machines will come to picture. Okay, I will tell you each and everything. Just what I am saying is what is the outlet. See, in workshop technology, we are using tools. In casting, we are casting and welding is comes under manufacturing methods. And after manufacturing methods, we are going to do machining operation. In machining, we are using lathe, you can use a machining operation, and milling, you can use a milling machine, you can do that machining operation, you can do the shaping operation, you can do the grinding operation. These all are, only thing is that removing excess material, removing excess material, so that finally product will come to picture. That's why this is called as production. Finally, product will come to picture. Finally, this is called as production. This is the manufacturing system will be happens like this. Whereas it starts from workshop technology, you are using tools and measurements, whatever the requirement, you go for manufacturing. After go for machining operation. Finally, you will come with a product. That product you can use it in the specific applications. This is overall entire about the production. And in mechanical, second category is thermal. In thermal, you are learning about the basic thermodynamics. Basic thermodynamics. And next, you learn about the IC engines. And next, you learn about the steam power plant and gas turbines. In thermal part, we are learning in thermodynamics. In thermodynamics part, we are going to learn about the all application. Like what is the principle of first law of thermodynamics and second law of thermodynamics, zeroth law of thermodynamics. Then next, these two are comes under applications of thermodynamics. One is IC engine, another one is the steam power plant. In basic thermodynamics, we are going to learn, first of all, just imagine thermodynamics. Thermo means heat, dynamics means motion. When a body is under rest, it is called as statics. When a body is under motion, it is called as dynamics. Motion means some work which happen. Heat and work. In thermodynamics, only we are discussing heat and work. Heat is also energy and work is also energy. That's why one of the application is IC engine. IC engine. Only in IC engines, heat is converting into the mechanical energy. Heat is converted into the mechanical energy. That's why how heat is converted into mechanical energy. How heat is converted into mechanical energy. How heat energy is converted into mechanical energy. Energy, heat energy is joules and energy is joules. One of the application is IC engine. In bikes, example, scooters, lorries, buses. These all cases, heat energy is converted into the mechanical energy. Heat energy, where it is coming from? Heat energy, where it is coming from? In that, we have to study the laws of thermodynamics. Laws of thermodynamics. In basics, we are studying the laws of thermodynamics. And next one, properties of substances. Next one is properties of substances, pure substances. Properties of pure substances. A pure substances meaning water we are considered as a pure substance. In thermodynamics, only we are studying about the single substance that is called as gas. Here, pure substance you are considered as a water. In thermodynamics, pure substance you are studied as a water. Here, it is a gas. What is the difference between the gas and water? This is in the liquid state. This is in the gaseous state. You heat the gas, you heat the liquid, it will convert it into the vapor. You heat the gas, hot gas. If you cool the vapor, it will convert into the liquid. If you cool the gas, it converted into the cold gas. If you expand the gas, it is expanded gas. If you compress the gas, it is a compressed gas. That means gas remains in gas. Gas remains in single phase. But if you coming to the water, if you heat the water, it converted into the vapor. If you cool the vapor, it converted into the liquid. That means it phase change will be happen. That's why one of the pure substance is water. We have to study the properties of the water. How to study the properties of the water. That's why we have to separately study the what is the properties of pure substances. This is we have to discuss in the basic thermodynamics. And next we are coming to the applications. How IC engine is working. How IC engine is working. In IC engine, it works on IC engines. It is SI engines and CI engine. SI engine is works on petrol. CI engine is works on diesel. So that operating cycle is auto cycle. This operating cycle is diesel cycle. That means we have to study the cycles, auto cycle, diesel cycle, different cycles we have to study. Suppose if you mix it auto plus diesel, it is combinedly called it as a fuel cycle. And next, linear cycle, Stirling cycle. We have to study the different cycles, auto cycle, diesel cycle, fuel cycle, linear cycle, Stirling cycle. That means this application works on one cycle, that is IC engines. It is two types of engines is there, SI engine and CI engine. SI engine is working on petrol. CI engine is working on diesel. Petrol is running with that cycle is auto cycle. Diesel is running with a diesel cycle. Combination of auto cycle plus diesel cycle, it is called as a dual cycle. And next remaining some of the cycles will be there. One is linear cycle, another one is the Stirling cycle. Okay. And next, this IC engine, it will be some of the phenomena will be there and knocking phenomena. Due to the continuous operation of this, the components of an IC engines will get damaged. That's why we have to learn some of the phenomena, knocking and detonation phenomena we have to study in IC engines. Regularly, we are using these engines, petrol engines and diesel engines. That's why this will coming to picture as knocking and detonation problems. To avoid that, in this we are studying IC engines. How we are avoiding, how you can run the vehicle. Sometimes that IC engines comes to boring. To avoid the bore, how you can eliminate the that operations. That means we have to maintain some efficiency standards. That efficiency standards is thermal efficiency standards, mechanical efficiency standards, and air standard efficiency. We have to maintain that efficiencies. And at the same time, we are learning about the brake power, indicated power, frictional power. These terms also we are discussing. This depends upon the all efficiencies. And next, suppose if you are using an IC engine, how you can say mileage in mileage operations. For that, we have to learn the one concept is for mileage. We have to learn one concept is specific fuel consumption. Specific fuel consumption. In that IC engine, we are discussing all these parts. And third one is, and third one is steam power plants. And next one is gas power plants and gas turbines. These two are called as EC engines, external combustion engines. IC engines means internal combustion engines. EC means external combustion engine. Combustion happens outside the cylinder is called as external combustion engines. Combustion happens inside the cylinder is called as internal combustion engine. Combustion happens external to the cylinder. One of the example is steam power plant. Another example is gas power plant. Steam power plant and gas power plant, these works on two different cycles. One is Rankine cycle. Another one is Brayton cycle. See how you are converting steam. Steam, first of all, how you are producing, first of all, input is water. See, this is gas, it is available in nature. Water, if you heat the water, it will convert into the vapor. If you heat the vapor, it is converted into the gas. See, if you cool the vapor, it will convert it into the water. See, gas, it is existing in a superheated condition. Gas existing in superheated condition. This superheated gas, like a in boiler, it is produces. Boiler, it is produces. This boiler, it is sending to the turbine. You will get a mechanical energy. See, here produces heat. That heat is superheated condition. That heat, that is steam. That steam is entering into the turbine. That steam entering into the turbine, you are produces work. This is called as a steam power plant. Steam produces power. That's why it is called as a steam power plant. In the same case, if you suppose if you use a compressor, suppose if you use a compressor, suppose if you use a if you use a compressor, it produces entering compressor, gas compresses, it and sent to the turbine. It sent to the turbine. High amount of gas is entering into the turbine, it produces power. That type of turbine is called as gas turbine. That type of power plant is called as gas power plant. The type of power plant is called as gas power plant. In this part, we are studying about this cycle is called as a Rankine cycle. Sorry, Brayton cycle. This gas turbine power plant is operating on Brayton cycle, and steam power plant is operating on Rankine cycle. This is just basic introduction to the thermal. And the last other part is design part. In design part, three different categories will be there: engineering mechanics, solid mechanics, design of machine elements. First of all, in engineering mechanics, we are studying about the static loading, mostly static loading. In strength of materials, we are studying about the plastic nature. Plastic nature. In design, plastic nature with applications. How you are designing each and every component. That design is taking care of that part. These two are only depend upon the loading conditions, static conditions and plastic nature condition. See, this is rigid nature. Like all bridges structures will be there. This is comes under rigid structure. And strength of materials, it will solid mechanics. This is mostly dealing with the plastic natures. But plastic nature is ductile material, brittle materials. These are we are studying in strength of materials. In design of machine elements, all components we are designing that components. This is comes under within the factor of safety limit or not. Factor of safety limit or not. Suppose if it is exceeded factor of safety, that material will go failure. That material will leads to failure. Suppose if any plastic nature is there, if plastic nature, these two types will be there. One is failure. What is failure condition? Failure condition is okay, just two times. One is failure, another one is fracture. Failure condition is suppose if you take a fan wing, this is the fan bend. Fan wings will be there. If suppose fan wing will be there, see that this will be the bend will be happens. Fan wing bend will be happens. This is problem. That means failure condition. Fracture means it's separated into two parts. Fracture means it's separated into the two parts. Two parts. This is the separation. This is the fracture. Failure condition means suppose if any simple bend is there, any simple bend will be there, it will comes under a unwanted loading, unbalanced loading. This unbalanced loading it leads to the failure of a component. That component it is designed re again that component will have to design re again that. So in that we are studying the design part, we are studying the engineering mechanics part, strength of materials part, and design of machine. In strength of materials part, we are studying the material properties. Material properties. These material properties also will have a one separate subject is there, metallurgy or material science. Material science. What it will decide the metallurgy and material science. Suppose if you are designing a bench car, if you are designing a bench car, if you are designing a bench car, but material selection is if you are using a thermocol, you are design excellently, you are designed a bench car. You are using a thermocol sheet. Is it fit for riding? It's not fit for riding. So that what we have to do, that material selection is very vital role. So that's why we have to study the material properties. That material it will go for metallurgical conditions or not. That's why we have to study material property. That's we are using a metallurgy and material science. This subject will help you the wherever you have to use the what type of material. That material is a ductile material, that material is a brittle material. It will decide this subject metallurgy and material science. This is the overall entire about the mechanical subject. See, only in mechanical means we are dealing with machine components. Machine components. Example, this machine components means bolts, nuts, screws, rivets. These all are joining points. These all are joining points. These all are, it is under factor of safety condition or not. If any component is there, suppose if the aircraft is running at high level or high altitudes, suppose if any one bolt joining is missing, one otherwise any one nut or screw joining is missing, at the same time rivet jointing is also happened. This rivet jointing is also semi-permanent joint. This joint is also missing. That entire component will leads to the separated into the 2 points, that is fracture. Separated into 2 parts, that will comes to the fracture. That fracture is a permanent failure. That fracture is a permanent failure. That means it will separate into 2 parts. So that first of all, any single component, that these all are the small things, bolts, nuts, screws, and rivets. These all are the small parts, but this is played a vital role. This plays a vital role. So that this machine components we have to design that. These machine components it will first of all it will any large components you can using as a production casting methods you can design it. Casting methods you are designing, and after that some of the materials you have to go for thermal treatment. Suppose if you are using as a iron also TMT bars. TMT bars. TMT bars means thermomechanically treated. Thermomechanically treated. Thermomechanically treated. That components we have to go for design. But design it is under what type of condition? It is under factor of safety condition or not. Suppose it will more than the factor of safety, that material will fail you. What is factor of safety means? Suppose if you take a lift, in that lift, suppose it will carry 15 members, but in that they mention only 10 members. Only 10 members. That means suppose if the it is in running condition, it is in running condition, that means it will running condition, it is a dynamic load is applied. First, initially it is in the lift, it is in not started condition, it is at the time static condition. The when the lift is running, a dynamic condition. At the same time, suppose if in the lift persons, whatever the people are there in the lift, they are moving around them. When the people are moving around that, it is in the dynamic condition. At the same time, it is in a impact load will be applied, and at the same time, shock load will be applied. That means unwanted loading conditions are applied. These unwanted loading conditions all will take care of the design conditions. So that some impact loads, sudden loads will be applied, so that we have to consider the factor of safety. That factor of safety will reduce the failure. Will reduce the failure. Whenever you reduce the failure, that material, as long as it is safe condition, as long as it is safe condition. Whenever it is a safe condition, that is fit for mechanically fit. That's why we have to learn the all three basic subjects: production, thermal, and design. These all things we have to discuss in detail. In detail. In detail, we have to discuss these all these subjects. This is overall entire about the mechanical engineering. In any competitive exam, either ITI exams, any technician exams, any grade exams, we have to study these subjects. This is the entire overall about the mechanical system. Okay, thank you.